Hello everyone and welcome to this webinar on Docker and Container Engine. I'm Ben Lambert. I'm a cloud technology instructor for Cloud Academy, and you can reach me at @SoWhelmed on Twitter should you want to reach out. Okay, today's agenda, I thought it'd be cool if we talked about Docker and Container Engine. For Docker, we're going to talk about what it is. We'll talk about why it's useful. We'll create a container image, and then we're going to create multiple containers. And then Docker is really, in effect, useless unless we can get our containers into production. So we're going to talk about Container Engine. We'll talk about what it is, why it's useful, and how to get started using it. So we'll start with the first question. What is Docker? Docker is a containerization technology. What that means exactly is containers allow us to wrap up any code that we write, along with any system libraries, into one package, and we call that package a container. This container will run the same way everywhere we run it because it has all of the files it needs contained inside. So from Docker's website, this is what they say about Docker. Docker containers wrap a piece of software in a complete file system that contains everything needed to run code, runtime systems, system tools, system libraries, anything that can be installed on a server. So a lot of people ask this, how are they different than virtual machines? Virtual machines run on top of a hypervisor, and the hypervisor emulates a computer's hardware. So every virtual machine has to include a full operating system because it's going to run on this fake hardware. And that can take up a lot of space. Containers, on the other hand, share the kernel of the host operating system that they run on. This makes them smaller in size because we no longer need to run an entire operating system. And it allows them to be more efficient because they don't need to run all of the extra stuff that an operating system runs. So containers become a much more efficient mechanism for bundling things up. Okay, here it is side by side. You notice that there's a layer missing. We don't have that guest operating system. It looks similar, but it's different. Docker bundles up all the files we need. It has all of the binaries and libraries that comprise the kind of personality of the operating system. And instead of running on a hypervisor which emulates hardware, we run on the Docker engine, which shares the kernel of the OS underlying it. So, won't building the containers take a while since they need to add all of those files? The answer is yes and no, but more no than yes. Let me explain. Docker uses this concept of image layers, and this is a really cool way to do things. When you use a Docker file, and we're going to talk about Docker files later, when you use a Docker file, every command basically gets turned into an image layer. So any files that get installed from that command become a layer. If we read this top to bottom, we have from Ubuntu latest, and then this command gets turned into what is basically a layer that comprises all of the files needed to become Ubuntu. And then the next command runs and it installs everything needed for Python, and then this next layer is all of the files that comprise Python. So it sits on top of the Ubuntu image. And then we come down here and we have this apt-get install Apache. So again, we create an image, and this image is our Apache layer. So when you start stacking these on top of each other, any files that are changed between them are going to be accumulated. So this allows us to build on top of it, and if something doesn't change, like this Ubuntu layer is probably not going to change unless the underlying Ubuntu image changes, and so we don't need to rebuild this every time. So layers make containers fast for building. We don't need to build the layers that haven't changed, so we only rebuild basically the code layers each time, and that makes it really quick. And now because of that, sharing these containers becomes faster because we only need to share layers that have changed. So let me give an example. If we're developing a website and we change some files in our application, and then we build our container and we push that to a repo, let's say it's the official Docker repo, Then some other developer wants to do some work. The first time that they download this container, it's going to take a little while because now they are downloading all of the images. But subsequent downloads are going to be faster because once they have all of these base images, they don't need to download them every time. They only need to download what has changed. And that's going to make sharing images or sharing containers much faster. All right, why use containers? Containers are a very hot topic right now, and people are trying to containerize all the things. Not everything needs to be put into a container. So what's a good use case for containers? Well, in my opinion, containers are a great way to implement a standardized environment. That way, it really doesn't matter which tools and technologies the developers select. As long as we wrap our final project in a container, we can deploy it the same way. So here's an example. Let's say we have a Python web application, and all of our stuff is done in Python. We're a Python development shop. At some point, we decide, you know what, we'd like to switch to using Go for a particular thing. We don't have to rethink how we are going to deploy this process with Go. If we have a process in place to deploy containers, then all we have to do is make sure our Go applications are wrapped in a container, and then it's deployed in the exact same way. So we get to standardize on our deployment mechanism, and that's a lot of value in there. Okay, I think we've talked about it enough, so let's see this in action. Now, I just want to say, Docker and containers in general are a broad topic. There's an awful lot that could be said about containers. So we're not going to cover everything. We just don't have the time to hit all of the topics, but we'll do a nice broad level of creating images using containers with Docker. We'll talk about actually how to get some containers into production, and then future courses that are going to be coming out will kind of fill in the gaps later. Okay, so let's close down PowerPoint. Okay, and we'll open our text editor. Great, and let's get a shell here. All right, here's what I want to do. I want to show you that I'm not cheating by, we're going to go to localhost 5000. Okay, site can't be reached. That's good. This is what I want to show you. I want to show you there's nothing running on our localhost port 5000. Now I want to go back, and what I want to do is going to build this, and we're going to say v1. I'll go back and explain what's actually happening with these commands, but we're going to start at the final result, and then we're going to work our way backwards. So I just want to build this real quick. Okay, and now I'm going to run this. Okay, what actually happened? We spit out a giant hash, and we returned to the console. Doesn't look like anything happened, but if we go back and we reload, and this might take a little bit the first time, it's going to initialize some stuff, so the first load can always take just a little bit longer. Okay, so what did we actually do? We started up a container that's running an application. Let's see what's going on with the actual application. What we have is a basic Flask application. There's nothing too fancy about it. We expose a route here for the index.html. We pass in some hard-coded data. We have a couple other routes. We'll talk about those later. And then we run it with the development server. This isn't how we'd run it in production. This is by no means an example of a production app. I just want to be clear. In production, we'd have it under behind a WSGI container, and then we would expose that through something like Nginx. So this is just a good demo. So let's see. All right, we built our container with the build command. Let's go back. And then we ran it. So what we did here is we said Docker build a container, and we're going to tag it with this tact flag as webinar flask, and then this colon is going to implement a version. We're saying colon version 1, and this period here is saying look in the current directory for the Docker file, and the Docker file is what is responsible for telling Docker how to build our image. So let's check out that. Let's check out the Docker file. So what we ended up with is we said from Ubuntu latest. And where does that come from? Because we never referenced Ubuntu anywhere. What happens is we have Docker has a registry where it keeps all of the base images, and we can see that if we were to Docker registry. Actually, we want to go to the hub. Let's go back. There we go. And we want to explore. Okay, so we use the Ubuntu image, and that's what we used here. It's this Ubuntu official. This is what's referred to as a trusted repo. Trusted is contextual. It doesn't mean that these are all going to be secure, but what it does mean is that these are community images that anyone can use. So we said from Ubuntu latest, and if we go into here, you can see exactly what that means. It means we're going to have an Ubuntu server, basically. We can look at the tags. Latest here, that's what we installed. We could have installed any one of these, 1404, 1204. So you see these long-term support ones. We can install any version that we want to use. And this is a really cool way to have a container that is of a base such as Ubuntu or Debian or whatever the case may be. And so we can go back. Come on, there we go. We go back, we're going to see that we have a lot of options. It's not just operating systems, but we have stuff like this. We have a Redis image. This Redis image is going to have Redis preloaded. So it's going to use some other operating system as a base, and then it's going to install its own files. And that's where these image layers come in handy, because we can have, let's say, Ubuntu, and then install our own stuff, and we give that a name, and then we could push that out to the community, and the community could use our container as a base for their stuff. And that's what we're seeing here, is all these different repositories. So we got a lot of options. So we go back. Let's figure out what else we have. So we say from Ubuntu. That means we want this to basically be an Ubuntu container. And then we start running some commands to actually install some of the files we need. Now, we could have used the Python container as a base, but I wanted you to understand this holistically, so I wanted to run these commands and create these different layers. When we run this apt-get update, it's gonna update the apt-get repo, and once it runs this command, it's going to create an image layer for that, and that image layer is going to contain all of the files that got updated. Since it's not going to update all that frequently, these files won't really change that often. And we do it again here. We install Python. Now this is our Python image layer. And then we want to copy our code into the image. So we're saying copy the app directory here. You see, I don't know if you can see my mouse wiggling. We're going to copy this into the /app folder in our container. And then we're going to set our working directory to be /app. What that means is all of these subsequent commands are going to take place in that working directory. It's like doing a CWD or a CD, change directory. So then we install our requirements. We're running a pip app. We're running a Python app, so we're using pip to install the package requirements. If you're familiar with package managers, we just have pip. It has a listing of all of the different modules we want to install and their versions. Okay, so that's what pip's doing. It's saying install all of the requirements from our requirements file. Okay, now we also have an entry point. By default, this is a shell, bash shell. I'm sorry, not a bash shell, just a shell. And that means anything that gets run runs in the context of a shell. So we could omit this, but then we would have to specify Python and our app. to say run the Python command and pass it the app.py parameter. Instead, we can override the entry point. So I'm saying use the Python command as our entry point, so anything that gets passed into this command is going to expect that it can be passed into the Python executable as a parameter. Okay, so this is saying run Python and then the app.py, which is our Flask application. Close that. So when we ran this simple little Docker build, it did an awful lot. It went out and built all of these different layers. Now let's run it again. Set focus here. Notice that it went really quickly this time. And you see this using cache. What happened is these layers didn't change. It didn't need to rebuild. So it just went through and said, yep, it's the same hash, and uses the cached version for all of these. Subsequent builds become faster because eventually the only thing that's going to change is our code, and we'll be able to compile this really quickly. Now we also ran with this command. What this is doing is it's saying run the command. Let's see if we can't make this a little bit bigger. Okay, we run with the tac d, which is daemonize. So it's going to run this in the background, and then we use tac lowercase p to bind the local port to our container port. So it's saying we want to make sure that whatever's running on the container on port 5000 gets exposed to our host on 5000. And that's why we're able to look at it on the web browser on our host and see it on port 5000. Then we're telling it what container image we want it to run, and specifically what version. Now, this is cool. Let's do this, Docker images. And we're going to shrink this up. We're going to be just kind of tweaking this as we go for each command. Okay, here's our v1. We have an image that was created 8 minutes ago, so we just created that. And we have a tag of v1, and it's our webinar Flask. We could also do Docker PS. And let's shrink that up. All right, it's a little small. Hopefully you guys can read that. And click the screen there. All right, so what this is saying is that go a little bit bigger. All right, what this is saying is we have one container process running. It's built on the image Flask, our webinar Flask v1. It's running this command Python app.py. It gives us the status, when it was created, how long it's been running, what ports are exposed on our host to the container, and a name for it. So now if we can go back to our web server, our web browser, and we run this again, it's going to load. Let's kill that container. We're going to do Docker kill. I'll show you this is a perfectly humane way to kill a container. Okay, now let's do Docker PS. All right, notice there are no containers running. We still have a Docker image built. These are pre-built containers, but we're not running any of them. The PS command shows us container processes that are running. The images show us containers that are built. So now if we reload this page, this is what we'd expect. We don't have a container listening for this. Now we can reuse, we can go back with our run command, cycle through. Okay, we can rerun this container because we've already built it. Nothing's changed. So now, go back to our browser, and there it is. So the container allows us to, we can build a container, we can start it, stop it whenever we want, we can kill it, and we can always start up a new instance based on the image that we've created. Okay, so this is all well and good. We have a container, which is useful. However, as developers, inevitably, we're going to work on some sort of microservice that is going to have multiple containers, or need to have some multiple container option, because we'll need like a database, maybe some sort of separate service that helps feed into ours. So how do we deal with multiple containers? Let's kill this. Let's do this handy command here. I'm going to copy and paste because why not? Okay, what this is doing is going to run this subshell command to list off all of the running processes, running containers, and grab their IDs, and it's going to pass it into the Docker stop. So it's going to stop any containers, and then that'll be okay. Now, like I said, inevitably we're going to have multiple containers. And so how do we deal with that? Let's do this. Docker tac compose, and we'll say up web. Okay, now we have some output. Notice what it says here. Creating container, and it's CA webinar DB1. We have CA webinar web1. We told it to create web. Where did this DB come from? We're going to show that in a minute. First, let's just look at this. We want to see open URL. I want you to see it started up our container, but it also started up a separate container. So if we close out of here, it's going to shut down the web one. It started up a database container as well, and we need to see why. So we're going to look at our Docker Compose file. This is cool. Docker Compose is allows us to create these YAML files that will specify multiple containers and how we want to handle them. So we start off by setting the version of the file format. This is so that Docker Compose knows what kind of attributes and properties to expect. And then we specify the services we want to create. We say we want a DB, and that's going to be the service name, and it's going to be an image based on the Redis. All right, so let's, where do we get Redis? We get it from page 1. We get it from right here. We specify the name. If we don't have it locally, it comes to this Docker Hub and it fetches it for us, which is cool. So let's go back. We're going to say expose the default Redis port, which is 6379. And then we want a service for our Flask application. We're saying build, and then we pass in this period. All we're saying to this is use the Docker file to build this. It's the same file we used when we created the Docker file or the Docker image before. The command is going to be the app.py, and then we're going to specify volumes. We're going to mount our app to /app. We're going to expose port 5000 to 5000 on our host versus our container, and then we say depends on, and this is really cool. Anytime we start up a web instance, we're saying it needs to have a database. So that's a really cool piece of functionality. It ensures that we always have the dependencies we need. So when we started it up, it created it for us. If we do docker ps, we can see that it started the database container and it's still running. So let's do a docker stop. I'll copy and paste this command again. And if we restart our web, it's going to start them both. So now, reload this. Awesome. This becomes a really handy piece of functionality. Like I said, inevitably as developers, we're going to have to run multiple containers, and using Docker Compose will make that nice and easy. Let's just show that Redis works. So we have a route here that says /redis/random/test. What this is it's going to pass in a key, and this is the key name. We're going to say hello, or let's just say greeting, and the greeting will be hello. Okay, so give that a second to run, and then when it's done, it's going to have set that value. And sometimes on these webinars, live code doesn't always go as expected. Anyway. So greeting hello. Make sure this is reloading. See if that's happy, that's happy. We're gonna list off the values. All right, there it is. Greeting, hello, random test. So let's look at the code that populates that so you know there's no voodoo going on here. In our app.py, what we have is, it's this route here. We pass in a key, we pass in a value, it tries to instantiate an instance of Redis, and then it sets the value and returns it. And then we have this get all, it just iterates through all the keys. Now, notice it uses host here. Up here we say, check in the environment variable for this string, and if it doesn't exist, use db as a name. Where does db come from? db is this here. This is our host name, and for our web server, this is our host name. The hosts file gets updated by Docker Compose automatically to add these for us so that we can reference our services by their host name, and that makes it really convenient in code. So, all right, we've talked about using a single container image and multiple container images, but basically all we've done is develop some code locally. That is fun, but it's not useful in a production environment. Containers, fun as they may be, are practically worthless unless we can have them running in production. The point is to have our environments the same as in development as they're going to be in staging and production. We want them to be exactly the same. So getting a container into production is key. When it comes to that, we have some options. We can use things like Mesos. That's an Apache platform. So we can use Mesosphere for that. We can use Docker Swarm. Docker Swarm is still in its infancy. It's young, but it's definitely getting there. My familiarity and preference is for Kubernetes. So I naturally gravitate towards Container Engine, which allows us to use Kubernetes, which is an open source orchestration tool, to work with deploying our containers on Google Cloud, and we can also deploy them anywhere that Kubernetes will run, which is basically everywhere. So let's see how to deploy our multiple containers, because I think there's a lot of demos out there that will show you how to get a container into any old production environment. But let's do multiple containers, let's make a change, and then actually update those containers, because I think that's valuable to see. If you can't get the containers into production and you can't update them, all of this is for nothing. It's just a fun exercise, right? So let's try this out. So we have Container Engine here. I've already created a container cluster. What this is we can set our cluster size, and in this case we have 3 servers running, and they're going to serve as the cluster of servers that will house our containers. And the way Kubernetes refers to a grouping of one or more containers is as a pod. And a pod will have some number of containers that represent a particular application. In our case, we have our Redis and our Flask. And then we have our service, which will expose those pods to us and allow us to browse to them. So I want to show also, this is the container registry. Remember, we looked at the official Docker registry here. You can push stuff to the Docker registry. You can also use something like this. This is the private container registry for Google Cloud for Container Engine. This allows us to submit our container images without having to worry about other people seeing or using them. So if we have containers and apps that we want private, we can use this. All right, let's see a demo. I want to switch back to our command line. We're gonna close out of this. We're gonna kill our container images. And I want to remove any of those images. All right, so now if we do docker ps, there's nothing running. Attack A, we can see anything. All right, so there's nothing there. This is great. I want to make sure we start fresh so we can see how everything works. Like I said, we're going to use Kubernetes. I've already done some of the setup, so if you were going to set this up yourself, you want to follow some of the instructions. If you're going to use Google Cloud, follow some of the instructions on how to get things like the Google Cloud SDK installed, which will give you access to the gcloud commands and some of the Kubernetes commands. Okay. So we need an image. We're gonna use the one. Let's use V8. All right. We're gonna use our V8 image. So it's already built. It's already pushed. We'll do another example. We're gonna push one to the container registry later, but we'll use this for now. So let's go back. All right, now, before we can get started, we need to create some things. We need a replication controller, and then we need a service to expose our pods to the world. Now, we're going to run this command. It's going to create a replication controller. Kube control create tacf rcfile.yaml. I'm going to run this. All right. It says replication controller created. What did we just do and why? Let's look at our replication controller file. It's another YAML file, and what this is doing is it's specifying a replication controller that will start up some pods. I want you to think of this like an auto-scaling group. If you're familiar with the terminology for something like AWS or Google Cloud, this is going to ensure that there's always 3 replicas of our pods. So we have an API version, that's v1. We have a kind, that's replication controller. And we're going to name our replication controller webinar flask RC. We want 3. And now this selector here is saying, I need to know how to find the pods that I will be basically controlling. So we're saying webinar flask v8, so name version. And then here we have our pod template. And that's what these are matching up with. This name here has to be matching this here. And this version here has to match this version here. And the spec for these pods, for this template, says we're going to have some containers. That container is going to be DB. It's going to use the Redis image. It's going to expose the container port 6379. We're going to have our web server. And it's going to use our image that we have stored on the Google Cloud registry, and it's going to be the V8 version. And again, expose a port. This should look very familiar. It's very similar to what we did in the Docker Compose. So here we call it services. We have our DB and our web. And here in our replication controller, we have a template for our pods. Remember, a pod is just a grouping of one or more container images, okay? And so this replication controller will ensure we always have 3 up and running. Now, let's go back. We're going to say kube control get RC. It's our replication controller. We desired 3. We currently have 3. You're going to eventually get used to these Kubernetes control commands. I call them kube control. That may not be the official pronunciation, but it kind of flows. So kube control is going to have some sub-commands, and once you get used to them, it's going to be very similar. The pattern is going to be, you're going to use get for different things, so we can do get pods, get services. We don't have any yet. We have the one. All right, that's from a previous example. And so we'll use kube control get and then something that we want to get. Same is going to be true for delete. We're not going to delete anything, but you'd say delete, and then you could say our replication controller and then the name of it, or delete some service. So the pattern will be the same. It's going to be familiar. It's kube control, get, set, delete, describe. Describe is useful. We can do describe RC, and we can give it our name. And it's going to give us details about this replication controller. So this is going to help us to kind of debug and find out what's going on. That's a really useful thing. Okay, we have a replication controller, which is like an auto-scaling group, and it auto-created pods for us. Those pods, again, are where our containers live. And now we need a service. Let's create this service. Same syntax, kube control create tacf servicefile.yaml. All right, it created the service. what does that service file look like? Let's take a look. We have an API version. We have a kind, again, of service. We have our metadata. This is naming the service. And now here under our specification, check it out, type load balancer. This is important. What it's going to do is it's going to basically expose our pods that are running to the world with the following information. It's going to say, look for port 5000 on the container, and then map it to port 80 on the load balancer. That's going to allow us to say whatever port we're running our thing on, in this case it's a web server, is going to be displayed to the world on this port, and we're going to use 80. Now this is another important part. It's saying selector. Name is webinar Flask. What is this actually looking for? Let's go back to our RC file. Notice here we have our template has a name. It's webinar Flask. This is what the pods are going to be named. So we're looking for any pods that are named webinar Flask, and those are the things we're going to expose to the world to use. All right, so we have a service. Now we're going to use cube control. Get service says. We'll just list them all. Okay, notice we have an external IP address. It took about a minute to actually create that. That's the typical range, somewhere between 45 seconds and a minute to create once you create a service. So now, in theory, we can copy this, and there we go. We have an application running. This application is going to be running here in Container Engine. Let's check this out. Here's our cluster, and we have some information about our cluster. So we're using Container Engine to spool up some instances of machines for us, and then we're using those instances to house our containers in pods. Well, that's the terminology for Kubernetes, is pods. So we have 3 sets of pods that are running to form this, and that allows us to very quickly set up a container and deploy it into the world relatively quickly. You saw. So we're running version 8. What happens if we want to run version 9? Notice here, I want to make note of it so that after it's changed, it will stand out. Underneath the logo, there's no text except for these 3 links here. Once we deploy version 9, it's going to say something there, and I'll let you see what it says, but it's going to change the words. So let's go back. How do we actually deploy our new version? We use the cube control rolling update command. I've got it pasted here because it's a bit of a long command. I don't want to make you guys watch as I type. So we have cube control rolling update webinar Flask RC. Now let's actually not run this command yet. I want to do this. I want to do get RC. That name there is the name of our replication controller. We're basically going to replace our replication controller. Okay, so let's paste that back in. We're saying rolling update, look for the webinar Flask replication controller, and then replace it with whatever's in this replication controller file v8. We're going to run this, and while it's doing its thing, let's look and see. ls. Oh, apparently I've changed it to v9 because we're running v8. My apologies. v9. There we go. So let's give that a go. Okay. Created a new replication controller, scaling up v9 from 0 to 3. We want 3 replicas. Right now there are 0. And then it's going to scale down the existing replication controller from 3 to 0. So it's going to invert the 2. Let's go into our file so you can actually see what's happening, and hopefully it'll start to make sense. This is a replication controller that looks just like this with a couple exceptions. We changed the version that we want to deploy, and these are all v8. That's the original version. And now we're saying the new replication controller is going to be the same name with a tac v9 at the end. We want to find the version 9 template for the pods, and that template is going to use version 9 here. So this is going to upgrade from our v8 version to our v9. And remember, those are already pre-stored in our container registry. So if we go here, v8, v9, all these previous versions from kind of playing around, but these are the two we're gonna look at. Okay, let's look and see the progress. v9 is up to 1. RC, the original, is down to 2. And it's going to keep kind of staggering these. Now, if we looked at the actual site, now we could reload this, and we will, and depending on which one we hit with the load balancer, we may or may not see a change in the text underneath the logo. So let's try it. There it is. All right, it says V2. A little confusing. Why does it say V2 when technically we deployed V9? It's because this is an application that I repurposed from a different project. The application was actually version 2 of the application, so that's why it says V2. But we can change that in just a minute and then deploy so we can see our new version. So if we reload, notice we go back to nothing under there, and that's again because it's load balance. It's bouncing between different versions. And do it again, and it's gone. Okay. The images for this are exceptionally large, so sometimes it's a bit slow. These are, like I said, I repurposed this app and kind of just cut it together so that it would work for this demo, but these images are not the thumbnails that the real app uses, so these are exceptionally large images. Okay, still staggering the two. Let's see. I don't know, maybe you can hear it. My laptop is sounding like it's about to take off. So if it flies into outer space, you'll know why. Alright, we're almost there. We're up to 3 versions for our new replication controller. We just have maybe one more. Yeah, we just get the one more we got to get rid of from our original. So you can see it does take a little while. It's not immediate for the cutover, but we have 3 groupings that it has to go through. So, okay, looks like it's almost done. All right, cool. Replication controller, Flask RC, rolling updated to RCv9. Let's go back, and now if we run our app, we should never see the previous version. It will always be v2 unless we see a cached version of the web page. v2, v2, v2. All right. It's all v2. That's great. So it's rolled out. It's deployed. This makes it a really nice and powerful way to deploy multiple containers. Again, those multiple containers come from our RC file. We go back to it, we're saying we want multiple containers here. We could specify just one if we wanted to, but there are different ways that work for deploying and updating single containers. It's a little different to do single versus multiple. You can do it the same way as the multiple, but there's no need. There's a different mechanism for that. So let's build one now. We're going to update it as v11 because we already have a v10. We'll update it and then deploy that so you can see how to actually build and deploy to Container Engine's registry and then deploy that. Okay, let's make a change to our text. Go back into the text editor and let's go into the template. We're going to go into the base. Let's do this. We're going to say greetings. All right, I can't spell today. Greetings from a webinar. And a smiley face, because who's not happy when we get to play with new technology? Cool. So we have a change in our code. What we need to do is build an image that we can deploy to Container Engine. Now, you saw us build an image before. We ran the build command. It's going to be similar. Difference is, we're going to call it V11. The difference is this. You notice this GCR, which is the Google Container Registry, .io CA webinar. Where does this CA webinar come in? If you want to build this yourself, you need to know. So it's the project name. We can get rid of that. It's the project name for the Google Cloud project. This is the CA webinar. So it needs to have that so it knows which project to map to. And then it's going to be the name of our container and the version. So, and then again, this period just says look in the current folder for our Docker file. Okay. So we've tagged it. We're going to build this. Notice using cache. We already have those, so there were no changes. We didn't have to do anything, but we haven't deployed it with these changes, so we had to run a few commands, nothing too major. And now we've built our container. Let's check Docker images, and we'll shrink this down. See here, we have our container image and our version. It's got its own image ID. This is its own hash that represents this particular image. It was created 11 seconds ago. All right, so we're gonna just zoom back in here so that it's easier to see. Now we need to push this to the registry, and to do that, instead of just using the Docker commands, we're gonna have to use the gcloud command. Gcloud is gonna kind of wrap the Docker command in this instance, providing us the credentials we need to deploy our app. Now these credentials are gained through the console. And let's go back to our clusters. And we'll click on this. And so if we wanted to connect, notice it gives us this handy command. If we want to connect to our cluster, we need to have the credentials for that cluster. So it allows us to set the project, get the credentials, and all that good stuff. Okay? And then let's close out of that. Great. All right, where were we? All right, we're going to run the gcloud docker command. We want to push this image, and we want it tagged as V11. And let's send that out into the world. Okay, now notice here, this is what we were talking about earlier. These layers were already built and sent, and nothing has changed in them. It uses these hashes to determine if it's changed. Nothing has changed, so it's able to just push the code that's changed. Again, this makes it efficient to share our changes and push them out, because we don't need to send out massive images all the time. And in 1 second it will be done. So let's jump into our container. Let's look at the registry. We'll drill in here. All right, we have version 11. Now let's go back. Okay, some updates to gcloud since earlier. That's fine. We'll deal with that later. Okay, now we want to actually deploy this. Do a rolling deployment. It's going to be similar, except we don't yet have the file needed to deploy, right? Before, we already had these pre-created. We had a V9 and a V8. So we need to do something to deploy our version 11. What we're going to do is we're going to copy this file, paste it, I'm going to rename it, and click here. Okay, v11.yaml. And now let's just do a find and replace V9 for V11 to replace that. And I'll skim through. Let's make sure it has everything we need. All right, this looks good. We're going to map the selector here, webinar flask V11 to the template webinar flask V11. And we want the same two containers, only this one, the flask version, is going to be V11. Okay, let's save that. And now we're going to do a kube control get RC. That's our replication controller. All right, that's its name, V9. So we need to replace V9 with whatever runs in the file of our V10. And let's just grab that code that command line image here. And where is it? Create pod file. I'm just looking for the update so that we have that handy. Okay, rolling update. Yeah, let's just do this. We'll do cube control, rolling tac update. We're going to do the name of our current replication controller. We're going to do tac file name, and then it's going to be rc tac file, and it's going to be v uppercase, yeah, 11.yaml. Okay, now again, it's going to take a little while. You saw how long it took before. It's going to take like 5 minutes to kind of swap over to make sure that it staggers. We always want to have a certain number of pods available to serve up the users, so it's going to progressively do that. And we can just check this out. Eventually it will say something other than v2. It's going to say what we told it to say. I think greetings from the webinar. There it is. So we have one introduced to the farm, and we're back to our others. So again, it's gonna stagger back and forth until we hit 100% deployment, and then it will only show our latest pods. So this is really useful. We have the ability to not only create a container, create multiple containers, and deploy multiple containers, and then update them in a method that's not going to cause downtime. That's an important part of operations, is to reduce that downtime. So that pretty much covers. Actually, you know what? Let's wait for this to get done. There's one more thing I think would be cool to see. Actually, there's two more things. We're going to do visual, Docker, visual. I think this is kind of cool. There it is. This is kind of a neat thing. Remember, we talked about layers and how they work. Every command basically creates all of the files needed for that layer, and then they get stacked on top of each other. It's kind of what this little icon here is signifying. So if we were to check out, let's say the Python image from the Docker registry, and we can give it a second to populate. Let's make sure to actually pick the right one. Python. All right, there we go. And let's find one to check out. Let's check out this on build. Yeah, that's fun. So save changes. Now this is cool. It's going to show us what all of these layers actually do, and this is neat. It adds these different files. It creates. It runs the command bin bash. Let's go back through. So each layer is going to do things that add new files or change files on the file system, and then they're stacked on top of each other to form the final image that comprise our Docker container. So I thought this was really cool, and I thought I'd share so you guys can kind of see and understand how Docker image layers work just a bit better. And so, all right, this is just about done, and then we'll run one more command. Hopefully it'll work. Hopefully I'm already authenticated. I want to show you how to use the Kubernetes user interface, and so we use the kube control proxy command for that. So this is down to 0, so this should be wrapping up any second. Okay, there it is. Now let's run this. Alright, so I'm gonna run this. Okay, do this /UI. Okay, this is really cool. We have replication controllers. See it here? Age, it's 3 minutes old. Tells us what images it's comprised of. Any actions that we want to do, we can scale. We can view details. So this is a nice handy user interface over what's going on. Look at it. We have our 3 pods. Remember, our replication controller said we want 3 replicas. Let's go back to that. We wanted 3 replicas of our pods, and that's what we got. And now they're all running, and we can see the memory usage, all that good stuff. And I think that's a nice, valuable thing. We could also scale. We're not going to add any more, but you look at the events, see what's going on. Let's go back. Let's go back to our home page. Here are our pods. We can deploy an app, upload some YAML. This makes it nice and easy to do some of this stuff from a user interface. We can also do it from the command line because that's useful to script stuff out, but should we want to, we have this ability. So that's kind of a cool thing. And now all of these are deployed. They should all say greetings from our webinar. Okay, that's pretty much all I have planned. Thanks everyone for joining. I think this has been a lot of fun for me, and hopefully this has been useful to you to kind of get a feeling for what Docker is at least a high level and how to get an application into production. We have a course coming out. It's going to be on Docker. It's going to be an introductory course to kind of go through some of the gaps that I've had to skip over to kind of get through this in the time we had. And then we'll be building on that as we build out the Docker learning path. So that'll be coming out within maybe a week or 2. So look forward to that. If you want to create a demo, an account to try this stuff out, you can create a 7-day trial account and kind of play around with some of the courses. Okay. Thanks everyone, and I look forward to seeing you at the next webinar. Thanks.